Hello guys. So this is the part 2 of the GATE 2023 question solution. So in the earlier video I solved some of the section 2 questions, and now I shall continue on that and solve some other questions of part number of marks 2. And after that, after completing this section, I shall come to the marks 1 section. So let's start. So in this video, first question is regarding the from quantum mechanics. You have been given that you have a um, 2D potential box. So this is the 2D box, right? First question. And where this is your x-axis, this is your y-axis. Your potential, so you know if the potential is 0 at the boundaries, this is trivial. But it has also been specified that it is 0 only at the, except apart from that point, at y is equal to L by 2. Y is equal to L by 2, it is 0. Now what is the ground state energy of the system? Given that this wave function that has been specified, it has energy E. So think about it. So what is the usual form of the wave function for a 2D infinite well box? It is psi nx ny are the quantum number associated with it is associated with the x and y coordinate. It is proportional to sine n pi x by L and sine n pi y by L. Now the wave function is only 0 at the middle of the y-axis. So it is only possible when your y, when your, so what the n is equal to 1 wave function looks like. It is like this one, right? If it is your axis x or y, and this is your psi, it is for n is equal to 1. And for n is equal to 2, it is like this, which has only one point where it is 0. So in x-axis, there is no point where wave function is 0. So the x-axis will consist of n is equal to 1 only. Because for any other a value of n, wave function will be 0 at some value of x apart from the boundary. So for x, nx is equal to 1 only. And for y case, it is only 0 at the middle. So for for this case, ny will be 2. And the corresponding energy has been given E. And you know that E is proportional some, like some constant, say it is E naught into nx square plus ny square plus nz square, right? And so in this case it will be E naught into, sorry, it is a 2-dimension case, so there will be no nz, sorry for that. So I have been, this is practice for me right now. So it is 2 squared, so it is like 5 E naught, and the ground state energy is E naught into 1 plus 1 square plus, sorry, it is not x, it is g, ground state 1 square, it is 2 E naught. So your ground state, and from this here you can find E naught is equal to E by 5, right? So it is 2 by 5 E. It is the ground state energy. Okay, pretty simple question once you understand what is the concept behind it. Now let's move forward to the next question. Question number 52. That is, your state has been given as half, half, and half minus half. So it is actually your spin quantum number. It is your z component of the spin is denoted by ms. Okay. So you've been asked to find the average energy or the expectation value of the Hamiltonian in this state, it is given as 4 lambda by h cross square to s1 dot s2. Right. Now you know that s1 dot s2 can be written in a very simple way in terms of the raising and lowering operators, like s1 dot s2 is equal to, sorry, so I was just checking if the recording is working or not. Sorry for that. So s1 dot s2 is half into s1 plus s2 minus plus s1 minus s2 plus s1z s2z. Now you act this operator on this state. What you will obtain is, so first think of this case. S2 minus will act on this and make it 0, right? So this term will not contribute. S2 plus S2 plus act will this one and make it positive 1, and S2 minus act will this one and make it negative 1. So it will be like half into this acts on this one, it is h cross square, because this two term will give h cross and h cross. It's like half into minus half. One will make it down and one will make it up. Okay, due to this term. And what is the z component gives? Z component gives half h cross into minus half h cross into the same state, right? The same state, half 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 minus half. When you take the expectation of this quantity, like on the given state as specified in the question, so this is the state that I am denoting by this one. Okay, so this will not this term will not contribute, because this will is a completely different state than this one. Only thing that will contribute is this term, right? And which is minus 1 by 4 h cross square. And in the question it is given, find the expression of h, and h is, so it is 4 lambda by h cross square, 4 lambda by h cross square into s1 dot s2. Taking the average is, you give 4 cancels out and only minus lambda remains. So this is your answer. Okay. Now the next question is from this Balmer series of hydrogen atom. So let me just solve it. The question is a bit lengthy. So what you do is, what is the Balmer series? So where wavelength is proportional to some Rydberg constant into 1 by 2 in final minus 1 by n initial, right? So it's n squared here. Now you have, and the fringe width in Young's double slit experiment beta is lambda into capital D by small d. So it doesn't ask that. So for different values of lambda, or the different spectral lines mean different values of lambda, right? So how would you need to change this small d, that is the distance between the slits, so that your beta, this fringe width for all these colors are same. So this lambda, as lambda changes, your, so like let's find how it should match like this. So your beta has to be constant, right, for different values of lambda. So let's make it r into n prime. Sorry, let's make it 1 by n prime. So lambda and say 1 by r is equal to r prime. It's okay. So lambda is equal to r prime in prime, where r prime is equal to 1 by r. So it's a constant, so it does not matter. So it is d by lambda has to be constant, right? Circular d by beta for fringes to be constant, and lambda is r prime n prime d by beta d by n prime is equal to d by beta. So for beta inside into some r prime. So for different values of lambda, your n prime changes, but your d has to be changed in such a way for beta to be constant that d by n prime, this ratio is constant. So your new d, so if it is your d prime, so your new d prime has to be multiplied by 1 by n prime, right? If you multiply this d prime by 1 by n prime all the time, then for all this lambda, your fringes will be same, because this part will be constant. Then all terms are here are constant. What is 1 by n prime here? You can see from here 1 by n prime was 1 by 2 square minus 1 by n square minus 1 by n square. So it is basically 4n square n square minus 4. So this should be the answer. Yeah. Okay. Let's move to the next question. Under parity and time division, which is odd and even. So let me just tell the answer here. That is, P is odd under parity, T, and mu is odd under time reversal. Why so? That's the next question. You can think of P like this. So like P is related to electric field, right? P is equal to some constant into E when this electric field is low. You know, it's like a measure of electric field. Now you can think like what is electric field? So if you set up a charge plus something here, right? Now you have an electric field generating from this position. Now you set up any position R here. From here, so electric field at plus R and electric field at minus R cannot be the same usually, because electric field decays, right? It's like 1 by R square, the magnitude becomes 1 by R square, but it's a unidirectional, like it's like it's like what can I say? So 1 by R square into R cap, like its curl is 0. So there is no rotational symmetry usually in electric field. So R and minus are usually different in electric field. So its parity is not conserved. So electric field is odd under parity. But if you think of magnetic field and other things, so what is magnetic field looks like usually this one. It's curly, right? So it doesn't matter you take this one or this one. So sorry, it is, as the curl is 0 for magnetic field. So these things plus R and minus are same. So this is not a good explanation though, but you can intuitively think like this. And also why magnetic field is odd under time reversal? Because say what does time reversal mean? So if something goes this way in time, say a charge is going this way in time, and a time reversal it will go this way in time. So when the charge moves in opposite direction, so if there is a wire, charge is moving this way, then magnetic field will take some direction like this one, depending on some thumbs rule or like that. Now if the charge moves in opposite direction, the magnetic field direction will be reversed. So it's not same, right? So it's the odd under time reversal. Now next question from complex analysis 56. It is function f of z is equal to z square sin z by z minus pi whole to the power 4. So what are the poles and residues of this system? So what will be the poles? So let's around z is equal to pi, right? What is the poles? So let's expand it around z is equal to pi. It's z square. Nothing to expand here. It can be expanded as z minus pi minus z minus pi whole cube by 3 factorial, that means 6 plus something something. Okay, by z minus 4, z minus pi per 4, 4. So you clearly see that uh, your z square into your z minus pi cancels out, 1 minus z minus pi whole square by 6 plus something something by z minus pi whole cube, right? So this is a so this is a pole of order 3. And what will be the residue? Residue will be usually residue is the coefficient of the 1 by z minus pi term, right? So it is minus z is coming at pi square, it's pi square by 6. So pi square by 6 is the residue of the system. And but in the option there is no pi square by 6 or minus pi square. There is only one correct option will be pole of order 3. That's what I think. Let's jump to the next question, question number 57. It is given that your disk is rotating with velocity v at position at point r is velocity given at omega r, and the angle will be theta cap, right? Because this is the theta cap direction, this is the r cap direction. You have to think of it like that. And what is the divergence, curl, etc. they have asked. So its magnitude is basically omega r. So the first option is gradient of v. What is the gradient of v? You can use the formula and see the gradient of v. The gradient of v will be basically del v del r, that is omega into r cap, and there are no phi or theta components, so that is omega r cap, and value of omega has been given as 2 radians per second, 2, okay, 2 r cap, and this matches with option A, so option A is correct. Then it comes divergence of v. So you can see, so without even doing any calculation, what does divergence measures? Like it measures like in like how much it um, spreads out from a certain point, and you can see there is no spreading here. Like it's same in, it's like there is some rotational symmetry, but nothing is like going compressing. But you can also do the maths and see that. So see that divergence of v is actually 0 here, should be 0 here, but the answer has been given as 2. So that should not be the answer. So B is wrong. Another option is the curl of V. What is the curl of V? So if you can use the formula, you can see that curl of V. Only term will come from the last Z component. So what is the contribution of the Z component? It is 1 by R del R of R into A theta. That means omega R into omega R into minus del into Z cap. So it is given as 1 by R omega into 2R square is 2R. 2R square is 2R. So it is omega 2 omega. So it is, the answer will be, when omega is equal to 2, so it is 4 Z cap. Is the answer, and this has been given as the answer. Correct. So option C is also correct. Let's look at option D. Option D is given Laplacian of V. So what is it? You can use the formula again and see that your only the first term del 2 of V is first term is 1 by R del R of R into del V del R. So which is omega basically. So basically R cancel omega by R. And when at R is equal to 1.5, R is equal to 1.5 means 4 by 3. Or am I wrong? Sorry. Let's write it. 15 by 10. Sorry for doing this. So it is basically 3 by 2. Sorry. Uh, so now 2 by 3 by 2, it is basically 4 by 3. Okay, at R is equal to 1.5. So it is the correct answer. So okay, so that this concludes the this part's video. So in the later parts of video, I shall come up with some more questions. So till then, bye bye.